Welcome to Maven's Talk series. This session is about SRE automation, use cases. Programmed by Digitarati, India's first IT finishing school.
As you know, with the advent of onset of cloud coming into play over the last several years, the need to balance your frequent releases of your products or solutions to your end customers, and the need to be ensuring a stable system as well. So there's this constant tussle between the two in terms of how do you manage stability, at the same time how do you ensure reasonably good release velocity where you are constantly keeping your customers engaged. And from the earlier definitions of stability or reliability or resilience, as you see in the bottom of the slide, the expectation has become more and more stringent in terms of what is stability. So in addition to just being the system being up, it should be error free, it should give you the right data, the response time should be in milliseconds, and there can be several hundreds of users. There can be spikes, ups and downs in terms of the usage, and the system should still be able to handle that without any challenges as you are in parallel releasing new functionalities. So that's the bottom line, what an SRE engineer kind of has to manage on a day-to-day basis. So this is a quick background on the drivers for SRE. So now with products coming on a very fast pace and the need for you to deliver new functionalities and features every day, we need to start thinking about the operations also like a product, right? So how do you ensure more and more capability of automation, self-service, right? And enabling some checks and balances in terms of controlling your environment to enable that reliability, which is what the SRE engineer is constantly looking at. So we broadly break it down into these three different buckets, which is basically discover, which is where you are ingesting data from all different distributed applications, monitoring and building alerts, able to search and resolve your incidents when they come up, and how do you isolate and then recover your systems. Finally, building intelligence, where you're able to adapt and analyze and prevent issues going forward. So this is in a nutshell what you're driving towards. And in each of these aspects, you can build in capabilities in terms of automation. For instance, how do you ingest data from logs from your different systems? Obviously, in the cloud platforms, the hyperscalers provide you capabilities to do that. How do you enable observability telemetry on your systems so that you're constantly looking at different metrics that you want to monitor depending on the need for your specific applications and their business criticality. So it could be throughput, it could be latency, it could be utilization. So depending on the different needs, you could set up these monitoring metrics, and then obviously based on your experience, you can set up alerts for engineers to kind of get intimated when something happens and be able to resolve those issues. The typical benefits that you will get through automation while leveraging an SRE capability is in terms of bringing that sense of productization, as I called it. So start thinking about the whole platform as a product, and how do you bring in level of automation in each aspect, whether it is configuration, whether it is policy, whether it is security, or whether it is, like I mentioned in the previous slide, in terms of your metrics, right? And then slowly moving towards bringing in an intelligence into your whole reliability, monitoring and capability. So there is a journey that you have to follow, and the need for this is obviously that today, or at least a few years back, when we were looking at doing manual deployments and trying to increase the release velocities, you often had a lot of failures and issues. And the whole idea of bringing in SRE is to bring down those failures and in terms of repetitive issues that you encounter by bringing in these checks and balances, whether it is automation, whether it is self-service or self-healing, or bringing in new concepts in terms of testing your environments through right now, in terms of the benefits and how does automation enable you to reduce and bring in more velocity of your releases, but also ensure that there are no or minimal faulty deployments. And at the same time, as part of your release, how do you bring in capabilities of failure mode effect analysis, chaos engineering, so that you are able to address issues even when they happen in production? How does your system fail gracefully or react to failures? These are some of the areas that site reliability practices will help. Broadly, if you look at it, the SRE services typically cover these four buckets. This is how we practice it, and essentially incident management, problem management, business continuity, environment management. It's not very different at this level to what you would perhaps be doing earlier in terms of traditional production support. However, what has changed now is in each of these pillars, the inclusion of tools and automation capability. So, for instance, in incident management, we now have standard methodologies of how do you go about defining your service level indicators, service level objectives, therefore your SLAs. How do you monitor them? How do you set benchmarks? Through tools, then you can set up alerts and measure that, right? And then you also have standardized reports that can be generated out of these tools for you to review on a periodic basis, which can be automatically sent to you for review. Then in terms of your problem management, how do you ensure that you consistently move towards automated remediation? And how do you bring in better ways of doing root cause analysis of your problems? And then based on the outcome of the analysis, how do you feed back into your systems for them to become more resilient and more fail-safe? Then, of course, I talked about chaos engineering, test data management. So how do you manage test data? How do you automate your test systems? Then, of course, the DevSecOps and bringing in the governance part of it. So there are two schools of thought. I thought I'll bring that up here. So while we are talking about SRE here, there is also a school of thought that the SRE and DevSecOps go hand in hand, because while the end goal is to increase your release velocity and maintain stability. So these two teams have to work cohesively. They can't work in isolation, both in terms of the governance and in terms of some of the overlapping functions that they may be. And I will give some examples of our experience of how we are doing it. Certain customers where, for instance, in a customer based off the Asia Pacific, one of the banks, where we are doing a microservices, monolith to microservices migration. At the same time, once the microservices go into production in a gradual manner, we have to build the SRE support L2, L3 kind of a support standpoint. And what happens oftentimes is to have skills which the development team has in terms of managing the L3, which needs to be there in the SRE team as well for faster resolution. So we have built a mechanism of a rotation of the teams between the two groups, the SRE group and the build and release group. And that way we kind of cross-skill and upskill the teams, where we are able to get a stable mix to address both development as well as post-release. So this is typically the automation stages that we follow. Essentially, starting with baselining or understanding for a customer, and establishing certain tools, defining what kind of parameters that they want to kind of monitor and build those tools to set up those parameters, and then start looking at gradually migrating, like I said, to automated remediation, automated of issues, uh, failure injection deliberately through chaos engineering practices, where you define the hypothesis for failure of your different systems, set up those failure injection of your system. Yeah. So this is the typical cycle that we adopt, starting with setting up of tools, identification of your KPI and metrics that you want to manage. Then these tools enable you to set up those metrics as well as monitor, setting up your alerts, etc. Constantly get notifications of that. And as you continue to monitor that, you start building your experimentation in terms of deployment as well as testing and failure management. Then you move to the final stage where you start looking at automation, analysis of issues, and then, of course, automated repairs, and then eventually also build in capabilities of self-healing and by bringing in tools in terms of artificial intelligence platform. This is how we approach in terms of how to go about managing the capabilities for any particular platform or an org. So there is an assessment mechanism of where the the particular enterprise is in terms of its SRE capabilities, and then we have mechanism beginner stage to automated to automatic eventually, and there are different interventions that you bring in terms of capabilities that you build in for enabling that journey, reaching a complete score of maturity near 10. You would obviously not have the complete maturity. It's a constantly evolving thing. The core capabilities that we normally look at in terms of the SRE would be beyond the traditional incident management, problem management, deployment, etc. Is in terms of the focus is on your SLIs, etc., as well as looking at toil reduction. I'll talk about this in depth in terms of how do you do that, and also in terms of collaborative effort, which is often not mentioned, but organization typically need for bringing in this collaborative culture as well as the culture and mindset for this. Traditionally, support and engineering typically looks at the shift model and then doing the manual, addressing the manual aspects of any failure or incidents. Significant shifting mindset required even in this skill set where you're constantly looking at what is called as toil reduction. So how do I look to reduce my support activities being manual so that the more I free up from the manual effort, I have that much time to enable in terms of core engineering activity. Same. And that's the constant drive that in terms of automating your SRE processes. In this slide, this is more in terms of how do you go through different we talked about. Yeah, so this is where you're looking at the different systems that you monitor and what are the different service level indicators that you would typically look at, depending on your various applications or solutions that you're in. Service level indicators, like I mentioned, availability, latency, throughput, or durability, right? And depending on the type of application, you will define these SLIs. And then based on this, you will define your objectives. Therefore, that will translate into your SLAs for your end customers, right? And then you're obviously also measuring, once you've defined your SLAs as whatever 99.9% or whatever, you start with a slightly wider margin of your error budget, but then as you continue to evolve and bring in more and confidence in your systems, you can up your SLAs and reduce your error budget by bringing down your toil in the system through automation. So these are different tools and tactics that typically we adopt at different levels, and obviously some of the initial levels are typically manual when you're setting up things in terms of tools, but once you start building your monitoring capabilities and you start enabling all your metrics through tools, which in today's world in the cloud systems are pretty much available through most of the hyperscalers, you can build on top of that and enable capabilities of automation, like I mentioned, not just from monitoring and alerting standpoint, but also in terms of your entire security, policy management, configuration. Right? All these aspects also can be automated, and that is where we bring in some principles, what we call as a code. So config as a code, security as a code, policy as a code. So you build these things so that for each of your workloads that you're managing, to create a sort of a mechanism called workload as a service, so that not only does it become repeatable units that you can set up for your different applications, but because they are repeatable, pre-built kind of configured kind of units, possibility of errors and omissions also reduce. So that is precisely the way that we operate. So you start with your core monitoring and telemetry and alerting, and then you start to, once you've understood all your applications much better across the different environments that you build these as a code components for policy configuration and build pipelines for your chaos engineering and testing, right? And then all of these enable you to ensure consistency and the ability to predict your stability as well as your release velocity. Now, in terms of managing your incidents, again, through tools like ServiceNow, Remedy, etc., once things are generated, if you're able to categorize through various tools that are now in place, for instance, AIOps tools are available in plenty, which can kind of enable some level of categorization and bring out some outliers in your incidents. So you can start creating a knowledge base of these incidents to start with, and as you build this knowledge base and the resolution, you can also bring in capability addressing some of these things through self-service for the support engineer, and over a period of time can also bring in for some of your standard things, you can also bring auto remediation. Also, what these AIOps tools can help you with is bring in some capability of showcasing some of the false positives that may come as part of your incident management, so that as you see them, you can look at automated ways to suppress your false positives, so that the support engineer is actually addressing only the actual incidents and not spending time or burning the several number of hours. And some of these experiences I can relate to one particular large engagement that we were doing in the last couple of years with one of the large managed service provider based out of US. We had taken over the operation of their entire backend systems, close to about 200 to 300 different systems spread across different technologies and across different pillars. So some of them were related to billing, some of them were related to their front-end customer portal in terms of servicing the different functionalities that the end user is demanding from their managed services platform. These backend systems were automating some of these processes through custom applications. Then there were infrastructure components that were to be managed. So in totality, we had pretty much 7-8 different pillars with different technologies, different tools, different capabilities that needed to be built, and there was almost a 250-300 member team managing these 300-400 applications 24/7 and servicing the customer with very stringent SLAs. We had close to about 48 different SLAs that were being met. And what we started with, one obviously was to understand the existing systems first, set these SLAs based on discussions with our customer and of course their SLAs to their end customers. And then once these SLAs were set up, first step that we had to do was rationalizing the number of monitoring tools that were being used by the different systems, come up with a unified or a standardized strategy to monitor and observe. Second step was, once we have established these incident management tools, the monitoring tools, look at a pattern over the last 2-3 years in terms of the incidents that have been coming, and we realized that there were these top 5 or 10 issues which were generating several millions of tickets, and about 30 to 40% of them were tickets that the support engineer used to look at the ticket, log in, look at the ticket, and then in most cases they were standard known alerts or warnings which needed to be closed. So these are some of these false positive kind of scenarios. So we collected a lot of data and then automated, while the alerts need to happen and they come into the system, we created mechanisms for understanding these alerts automatically and then creating a routine of which ones can definitely be closed by the system themselves versus routing it to the next level of engineering support. So we brought down the number of tickets to be addressed by the first level support by almost 50% through simple automation by looking at the historical data. And therefore, it freed up a lot of time for people to look at transformative initiatives. For instance, how do you reduce cost of licenses? Or how do you look at improvement in terms of the infrastructure or the deployment frequencies? Because a lot of these different environments were still being managed manually in terms of deployment. So how do you enable a pipeline to be created? How do you containerize some environments so that you get some benefits in terms of the cloud capabilities, and both in terms of repeatability of what you're deploying as well as monitoring the metrics that you want to monitor for the applications through the cloud tools that were provided. So the goal here was constantly looking at automating some of the manual work that the SRE support teams had to do, and then use the capacity that you get by reducing destroy to bring in transformation initiatives with the same team. And that is where the importance of that team having both the build and release skills as well as the support and engineering skills is something that we started with an initial balance, but then we created a sort of a pool, a shared services pool, which would address across the different lines of business. So this is just a few key things that typically you would manage in your SLAs at a user interface level, the key parameters that you will monitor and manage. Similarly, at a data level, what you will typically the APIs that you manage from a risk standpoint for your service level object. Just a guidance, but typically this is what in our experience we've been managing. From an end user standpoint of the availability, the latency, the user perceives the request and response, quality of service that you provide to the end user. So if users are requesting and over a period of time the performance of your grading, quality is degrading. So these are some of the things that you typically measure from the standard golden rules of SRE. Similarly, from a data processing standpoint, a lot of this can be configured as metrics either directly or through custom metrics on the cloud platforms today. You can derive and bring in these things directly on your, for instance, in your AWS or Azure, on your dashboards. Like in AWS, for instance, with CloudWatch, you can bring in most of these things Another interesting experiment that we are working with AWS is we are building what we are calling as a smart observability platform at Tech Mahindra, which will build on top of CloudWatch and X-Ray a pre-configured set of metrics, which would basically detect all the services that you are using on the cloud and enable the most relevant metrics that you want. Some of them are our own custom metrics that we have built, which are relevant for the different services that you may consume, AWS in this case. And also, it creates some enriched logging applications tagged and pushed into these dashboards, which will enable you to do better RCA for your incidents when they occur. And then, of course, by bringing in X-ray and some of the new features that AWS, we are also enabling a much more rapid drill down to or facilitating your investigation through rapid drill down into the actual segment or area where your application has any hotspot or any issue. Through this enrichment of customized metrics, we are able to get to the root cause almost 50% of the time than what is normally taken through default capabilities. So these are some of the things that you can look at building through some of these hyperscaler platforms and build on top of them with your own tools or custom tools or open source tools, like bring in capabilities from Grafana, Splunk, Prometheus kind of thing, and create your own visualization and metrics, which can enable you to resolve things faster. Site specifically brought in this is something that we are working with very closely with a couple of our engagements, where one is a retail customer, largest retail grocers in US, and another one is a bank in Asia Pacific, where we are working closely with the customer in terms of supporting them chaos engineering exercise, which I mentioned. So these are some of the areas that you can set up pipelines. Yeah, I have a slide on the pipeline. So yeah, so typically you will define the different aspects of failures that you can anticipate, and you can create your experiments and enable these chaos engineering pipelines in your systems so that you are able to test that entire workflow and do the assessment on these various parameters to ensure that your system is resilient, which is the end goal from an SRE standpoint, is to bring in and ensure these capabilities are met to the maximum so that your SLAs to your customer are at their peak. So these are some of the key areas in terms of the parameters that you can build in terms of your hypothesis in the chaos engineering. We use different tools that you can kind of set something similar. And again, these are representative tools that we have experience in, but obviously other tools as well. Build a complete chaos engineering pipeline and look at your service health and look at your different transactions and monitor your various KPIs that you may have, and look at deliberately bringing down failures to see how these KPIs are getting affected. I've already covered this, but just pause on this slide for a small time. So toil reduction is one of the key motivations, and this is the underlying foundational principle. How do you ensure that your repetitive role-based activities that how can you automate those things? Like I talked about, how do you classify, categorize your different alerts that you may have configured? And then once you have enough data, how can you perhaps reduce the need for the engineer to address those alerts? Can they be automatically addressed? And how can the system start looking at creating automated alerts? How do you bring in capabilities for self-healing? So look at automated discovery, look at the faults that may be coming in, look at your knowledge base automatically, to see if there is anything close to the fault that has currently occurred, and then look at mechanisms to remediate. If not automated remediation, look at recommending possible remediations to the support engine faster. This is a slightly deeper drill down in terms of what I talked about as a code service. So this is one of the automation at creating policies that need to be applied so that you can have standard policies to validate against when you're setting up workloads, clusters, right? So enable triggers to check these policies or validate these policies. So at what time do you want to, rather than having to do these daily, and you enable these as triggers that comes to the individual even if they are not yes, to be able to address these policy validations. In some cases, they can be perhaps auto-validated as well in terms of compliance checks. In most of these, I'm talking purely from obviously you can Kubernetes. So these are things that we are talking in the cloud native world or cloud ready world. It can equally apply on-prem for your containerized clusters of containers that you have. It's not necessary that this applies only to a cloud model. And this is in terms of policy management. So these are some of the typical setup and network related, security related, reliability configuration things that you can set up by default, which will enable you to manage your policies, whether it is for a security purpose, for a network access control, in terms of some of the best practices of managing your clusters. All of these can be automated by setting these things. And again, these are just representative. Like I said, we've kind of built something called workload as a service, where we have different components within the workload and also different components within your landing zone that can be pre-configured and set. So that in terms of deployment, in terms of managing them as a service becomes for the support of the release engineer. Again, the typical steps that you can kind of automate from a security standpoint. Right from your build phase, looking at your registry, your compliance checks, running and perhaps disseminating your risk reports. And so this whole cycle can be created as a service and enabled, which can significantly bring down the effort of support engineer. All that he needs to monitor is the execution of this tool and the reports that it generates. And if at all something fails, then address them. But that significantly reduces the role of trigger these steps in terms of doing them manually. These are some of the things that I'm sure each one of you would already be aware of, managing things on the infrastructure side as a code to do as much of provisioning automation, managing recreation of your events, failure events, etc. through code as part of your simulation scenarios. A lot of these could be automated to, again, bring in that predictability and reliability, both in terms of monitoring as well as simulation of scenarios where we that through automated flows. This is a slightly deeper drive down on the incident management and monitoring. So how do you look at the tool that you're managing for your incident management? We talked about this already. In terms of enabling categorization of your issues and then creating your escalation mechanisms how do you route to different categories and therefore to different people, or it could be to a bot which can address certain categories automatically, right? How do you define your run books and what's the workflow for your run books? How do you link some of your incident management capabilities to, like I said, bots or chat tools like Slack, etc., and also perhaps to other tools like Jira, etc. Integration of these things can enable faster resolution of issues. Some of the other things we've already talked about in the earlier slides, setting up of alerts, automated incident response, enabling logging, where I also talked about custom enrichment of your logs. Metrics can be further enriched in the monitoring tool that you're using and will enable faster resolution of incidents when they happen. And then, of course, the typical dashboards that you can build on these observability and telemetry tools that are available.